Hello guys, welcome to eGreen Academic's online solar learning. Now we will discuss about our module 2, that is solar PV design and layout. In our module 1 we have discussed about outlook of solar power. What are the different kinds of renewable energy sources? Then what are the different kinds of conventional energy sources which are impacting our global warming and climate change? What are the indistinguishable consequences that the conventional energy have? In order to make a solution, we also introduce variable kinds of renewable energy sources, and one of the most important is solar energy. Now let's look more into the solar PV design and layout in order to understand more about how it exactly works. Let's look, before going into the more technical details, we'll look more about first as an organization called Neutrino Energy Private Limited. Neutrino Energy provides renewable energy capacity building, CSR advisory and implementation, renewable energy service. Our motto is sustainable energy for all. Our main quote is go renewables. Your neighbors will think you did it for environment, but you know that you did it to save your money. Our main awards and recognitions from Harvard University, Young Leaders Debate by Masdar, then Nudge, the Climate Reality Project, founded by Mr. Al Gore, former US Vice President and Nobel Laureate. Ministry of Gender and Equality from Korea. Waka Waka, one of the biggest solar energy organizations working for below poverty line people in Netherlands. Now, how does exactly the solar PV schematic works? We have the solar sun, which continuously radiates sun rays, which normally gets radiated onto the modules which will be installed at your rooftop, and it normally generates a power into a direct current. Now, as most of you are aware about it, when our loads, that is fan, lights, fridge, then electricity switchboards, which normally consumes a power in AC. Now we need to convert the DC power into an AC power. So in order to convert that, we need an inverter which normally converts DC power into an AC power. That AC power goes to the fuse box, where the fuse box acts as a protection mechanism. If there is any fault comes from the modules or any kind of equipment which is installed at your home, it separates both the systems. So it is a protection mechanism which will be used. Now this protection mechanism have connection with the electricity loads, which is light, then other loads kind of TV, computer, fridge, and the fans. Now if you want, normally solar will only generate an energy during the daytime. What about the night time? If you want to consume an energy in the night time, we need to use a battery as an optional criteria. Now, how does they charge the battery? You need to install extra capacity modules in order to charge that battery. Now, battery normally charges the normally works on the charging and discharging mechanism, where the energy gets stored and consumed during the night time. Now, it is again connected to the meter, which will be used to meter your energy consumption, which is coming from the solar PV modules and which is also coming from the grid. Normally, when you generate an energy, solar energy, you will be exporting it to the grid, and whatever the energy is getting imported from the grid, which will be measured through this kind of a meter. So this has a bidirectional mechanism. So this is all about the solar PV schematic and how is exactly the energy is getting generated. Now, what are the different kinds of components which we use in solar PV system? First is a mounting system, which is a kind of a supporting structure which is made up of aluminum or galvanizing steel to place the modules on the mounting structure. Maximum power point tracking is a mechanism which uses a DC to DC converter to generate a maximum amount of energy by producing maximum voltage. Solar inverters, which normally convert DC power into an AC power. Cables and associated components to connect the whole solar PV systems, from solar PV modules to inverter to fuse box to battery, fuse box to meter to grid. So these are all cables and associated components. Combiner boxes, which normally takes huge amount of input cables from the each of the solar PV modules, and which normally converts that huge amount of input cables into one output cable, which normally goes into an inverter. Lightning protectors is a protecting mechanism which prevents this whole solar PV system from lightning. So this is the basic layout of solar PV system. Let's look at the more detailed version of solar PV systems, wherein you have the three arrays which are connected into a parallel. These are the three arrays which I am pointing out: first array, second array, third array. Each array consists of 16 modules, and these array are connected in parallel with the inverter, wherein it converts the DC into AC power, then it connects to the main distribution board, and then it has a meter which normally has export meter and import meter, and which then normally connected to the distribution network. Let's now talk about the solar PV modules. Now, solar modules uses the light energy that is coming from the photons from the sun to generate an electricity through photovoltaic effect. Now, how does this modules convert or generate an electricity? So, this module uses the wafer-based crystalline silicon cells. Now, this, if you can see this solar cell, which is made up from the silicon wafers. So, this is the one silicon cell, and the other modules that can be also prepared from the cadmium telluride solution. So this is the solar cell which is mainly prepared from the silicon wafer. So group of silicon wafers normally forms up a one solar cell. Now group of solar cells forms a one solar module. Group of solar modules forms a one solar panel. Now group of a solar panel which forms a solar array. So it is a kind of all grouping mechanism from wafer to solar array. Now then it is connected to the other balance of systems. What are the different types of solar PV modules? So first is a monocrystalline. As you already guessed it from the name, mono, that is single, and crystalline, crystal silicon. So it is made up from the single crystal of silicon. Now how it appears, it will have a smooth texture and you will be able to see the thickness of the slice. These are the one of the most efficient solar PV cells and of course most expensive to produce. The next category is polycrystalline. That means poly means multiple, crystalline means crystalline silicon. So it has made up from the multiple crystals of silicon. So they are kind of a reflective appearance, and again you can see the thickness of the slice. And these are the less efficient than monocrystalline and of course less expensive than the monocrystalline cells. Now we have the third is amorphous cells, which are normally manufactured by placing a thin film of amorphous silicon into a wide choice of surface, and these are the less expensive and less efficient. And if it is manufactured from the flexible surface, the whole solar panel can be a more flexible phenomenon. Let's look at the mounting structures. What are the different kinds of mounting structure that we use in solar PV systems? So we have the general schematic of mounting structures. We have this vertical rods which is made up of aluminum or a galvanized steel, and we have this shaft connected to the lower vertical rod and upper vertical rod, and which normally connects this horizontal rod for the supporting structure to the solar panel. Now these solar panels get installed on this supporting structure to have a more inclined view. So we have this elevation angle which is normally decided on the basis of radiation required at that place. So what are the different kinds of mounting structure that we use in this kind of a system? So in this kind of a system we use the fixed mounting structure, wherein we have the fixed elevation, so you cannot change that elevation at any point of a time. We have the single axis tracker. It is normally a sensor based tracker solution, wherein based on the intensity of a sun and based on the timing of a sun, like at 12 o'clock the mounting structure will be at 180-degree elevation because the sun will be exactly above on your head. This is about the single axis tracker. It normally rotates on the basis of intensity and radiation which gets placed on the solar modules. Seasonal tilt, it has the fixed plus variable kind of a mechanism, wherein it has a shaft and it is connected to the bolt which you can manually place, and which can manually adjust the angle of solar mounting structure based on the season, like summer, winter or rainy season. So one of the more important characteristics of it, what are the different kinds of structure used? Aluminum, stainless or galvanizing steel. Now it is normally inclined at an angle to the horizon. Then each solar mounting structure can be capable of supporting almost around 20 modules, and it can withstand speed up to 100 km per hour. And each structure has a provision for a junction box which normally collects the inputs from all the solar PV panels and normally converts into one single output, which normally then goes into a inverter. Maximum power point tracking. Solar cell generates maximum power at a certain voltage. This point is normally called as maximum power point. And the optimal operating voltage depends upon the irradiance and temperature. Like how much is the irradiance and how much the maximum temperature is, the maximum will be your energy. This is also called as a DC to DC energy converter, because in order to get the maximum energy you need to have a maximum voltage. So this DC to DC energy converter, which normally steps up your voltage and converts into a greater voltage level, and it's called as MPP tracker. A PV system with MPP tracker and MPPT system normally improves the energy yield of the system, because if you have a higher voltage it will have a higher current, and then higher current will have almost directional effect on higher energy. So let's look at the example wherein the current is at on Y side and voltage is on X side. So if you have the battery range voltage, the normal voltage from 10 to 15 volt, and if you want to increase it from 15 to 17 volt, we will use the DC to DC converter, that is maximum power point tracking system. And at 17 volt it will have a maximum energy generated from the section. So at normal you are using you are generating a voltage at 15 volt, but at MPPT you are generating a voltage at 17 volts. So of course it is increasing energy generation of a solar system. And normally it calls at PV, that is photovoltaic, I is current, V is voltage, IV curve. Solar inverters, as we have already discussed, these are normally used to convert the DC current into AC current, and it has four main types. First one is a central inverter, wherein the complete output of an array is converted to AC and is fed into the grid. And one of the largest inverters, normally the central inverters can exceed 1 megawatt of a capacity with weight over 20 tons. Second one is a string inverters, is the normally used for smaller levels of systems, which normally connects into parallel, and each string can be goes up to power range of around 1 to 3 kilowatt peak, and the weight is almost around 5 kg per kilowatt peak. Multi strings like this inverter can accept power from number of strings with different peak powers. Individual like each PV module has its own inverter rating, making its own power source. So these are the four different kinds of solar inverters. So energy generated by the panel in terms of a DC current, it converts that DC current to an AC current, and that is then transmitted to the grid. And normally it has also a mechanism wherein DC voltage will be a straight single curve, and AC voltage will have sinusoidal curve, positive and negative side. So it will have two switches wherein first it will convert into the positive cycle, and the second will convert into the negative cycle, and that will be form an alternative cycle mechanism. How does it look like? So it does look like this, wherein we have the inverters, which is normally a front view of it. So this is how the inverter look like. Now the cables and associated components, normally we use the special double insulated cables, which are normally ultraviolet and water resistance, in order to protect the voltage or extra surge from the earthing or solar PV system or from the load. Now the voltage drop that we normally follow in cables and associated component, which will be less than 2%. Since cable power losses are proportional to the square of current, because losses have been measured as like I square R, like square of current into resistance. So if we reduce the current, then of course the cable power losses will be less. Different types of cable that we use in solar PV systems, so as depicted in the visual. Now talking about the combiner boxes. So what does combiner boxes do? Combiner boxes just act as a junction. So wherein if you talk like a railway junction, wherein the lots of trains are coming up, and it acts as a junction area for the traveling passengers. So same like the solar PV system, wherein the solar PV panels, huge amount of solar PV panels, and the output of that solar PV panels, huge, that is multiple output that is coming into the junction box, and it collects all the inputs from each of the solar PV panels, and then it collects the it normally transmits the current from that junction box to an inverter. So wherein the normal module strings which are normally connected in the parallel. Now the fuses are normally provided within the string into the combiner boxes to protect the system against any kind of a fault. So we have the lightning house, and the main DC isolator switch is normally provided to isolate the PV system or inverter system in case of any fault that comes into the inverter or any kind of a solar PV modules. So normally the DC combiner boxes, which we call it as DC combiner box or a junction box, which look like this. So we have this number of inputs coming from this side, then outputs which is going from this side. We have the circuit breaker which is in parallel with this, then we have the output which is coming into the circuit breaker, then circuit breaker which follows the output, which normally goes into an inverter. So we have the microprocessors or relays which is normally communicated with circuit breaker for any kind of a faulty mechanism. We have the protection units. Is normally just like a home, when you have a fault it will automatically shut down and it will switch off the switches of all the electrical appliances, and it works like a same. If combiner boxes does not include a DC isolator, then it must be provided separately and be easily accessible. Since the PV array always produces a voltage when exposed to sunlight, it must be possible to disconnect it from the inverter for maintenance or testing. Hence, the isolator switch is rated for the maximum DC voltage and current of the array. So, before we take a recap of all these things, let's look at how exactly it generates an electricity. So, it's basically a small animation which will be shown here. So, let's look at the animation. So, we have the sun which is here, and then which has a photovoltaic effect when the sun rays are getting produced from it, and then this photovoltaic effect is getting generated. The DC source of current which normally flows into an inverter, which will be shown here. Now let's look at the process step by step. The sun which generates an energy which normally puts into the panels, which normally goes the DC current, and that DC current which converted into AC current, and this inverter which normally converts the DC current into an AC current, then it will be flown into a meter which normally meters the energy consumption, and that energy consumed will be done by the electrical appliances. Now here is all about the solar energy system. Now what are the importance? It is free and always used before any power from the grid. In the night, what happens? You don't have the solar energy to produce. Now what do? In that case, what we do is we take up a solar energy from the grid in order to fulfill our needs, and in the daytime we normally flows that energy into the grid. Now what is the important benefit for you? Importing energy grid, you will get money at a feed-in tariff rate. At feed-in tariff, which normally is a fixed rate for you, which will be paid by the utility, and if you get the money for importing an electricity into a grid, of course your energy bills will be almost reduced. So this is all about solar PV schematic. Now in the next module we will have a solar PV economics, like how to rate each of the systems. So till then, goodbye.